Whenever you ask something to an AI like ChatGPT, have you ever stopped to wonder what's actually going on inside its, well, mind? It just kind of gives you an answer, right? But the reality is so much more complicated and honestly, way more interesting. So today, that's what we're going to do. We're going to peel back the curtain and take a look at how these models really think.
And the main question we're asking is this: does an AI have any idea about all the other answers it could have given you? You see, when it starts typing, it's not just following a single script. It's actually starting a journey with a whole bunch of possible paths it could go down. And here's how to think about it. Generating a sentence for an AI isn't just one smooth action. Every single word, or token, as the folks who build these things call it, is a choice. It's a crossroads. And making a slightly different turn at one of those crossroads can send the whole thing to a completely different destination, a totally different answer. So that brings us to our first big idea. These large language models, these LLMs, they're not just pulling a pre-written answer out of a hat. No, they're actively navigating this huge space of possibilities. And a single word choice, something that seems tiny early on, can have this massive ripple effect, changing the entire final outcome.
Researchers actually have a name for this: token-level uncertainty. It's basically the AI's hesitation at every single step. If the uncertainty is high, that means the model sees a lot of different good ways forward. If it's low, well, it's pretty confident about the road it's on. And figuring out that hesitation, that's the real key to understanding what's going on in there.
Okay, so how on earth do you measure that hesitation? Well, the first thing researchers tried was, let's just say it was the brute force approach. They literally tried to map out every single possible path the AI could take from one starting point. This method is called forking paths analysis. And here's how it works. Step 1, you get the AI to give you a normal answer. That's your baseline. Then, you go back to the beginning of that answer, and at the very first word, you force the model to pick a different word. And from that one little change, that fork in the road, you let it generate hundreds of new answers to see where they end up. And you do this for every single word in that original answer. Yeah, as you can probably guess, this is a massive problem. It is computationally insane. We're talking millions of calculations just to analyze one question. It's a great idea in theory, but in practice, it's totally impractical. There just had to be a smarter way. And this is where it gets really, really cool. This is the breakthrough. Instead of trying to map every single road from the outside, the researchers thought, what if we could just peek inside the black box? What if we could read the driver's mind before they even make the turn? And the answer to that question lies in something called hidden states. Now, all that means is the internal pattern of what the neurons are doing inside the model while it's working. The best way to think of it is like the AI's private internal monologue, all the little thoughts that happen between it spitting out one word and the next. So this led them to their core hypothesis. Could these internal thoughts, these hidden states, actually tell you where the AI is going to end up? Could you look at this internal chatter and predict the final destination long before the journey is even finished? And of course, that leaves the next question. If you can read the AI's mind, can you influence it? This is where the research gets really exciting, because we're moving from just watching the AI to actually trying to grab the steering wheel. What the researchers figured out is that they could create something called a steering vector. Basically, they looked at the internal thought patterns of models that give answer A and compared them to the patterns of models that gave answer B. By finding the difference, they could create this little piece of code that, when you inject it into the AI's hidden states, it's like a little nudge on the wheel, pushing it toward the answer you want. And this one example from their work shows it perfectly. They gave the model a math problem, and for a while, it was really uncertain, hesitating between answers. But then, it generated the single word loss. And that was it. That was the point of no return. After that one word, the model was totally locked down on the wrong answer, and no amount of steering could pull it back. And you can see that so clearly in the data right here. Before the model said the word loss, look, the steering success was high. They could nudge it towards the right answer pretty easily. But the instant it generated that one critical word, boom, steering success drops to almost zero. The model had made up its mind. The window of opportunity just slammed shut. So the really crucial thing here is that this wasn't just a fluke. Across all of their experiments, they found this clear connection, a correlation of 0.64 between how uncertain the model was and how easily they could steer it. To put it simply, the more hesitant the AI is, the more you can influence it. So what does this all mean for how we understand AI? What's the really deep implication here? Is it all just about the words that pop out at the end? Or is there something much more profound going on inside that black box? To figure this out, the researchers did this really clever final experiment. They tried to predict what the llama model would say in two different ways. First, they used llama's own internal hidden states, its own thoughts. Then, they had a totally different model, Gemma, read the exact same text and then tried to use Gemma's thoughts to predict what llama was going to do. Now, if only the words matter, both of these should be about the same, right?
But that is not what they found at all. Check out these results. Predicting llama's answer from its own mind was way more accurate, a score of 0.11, and here at lower is better. Trying to predict it from an outsider's view was much worse, at 0.19. This is the smoking gun. It proves that the AI's internal state has special private information about its own next move.
So let's just boil this all down. What are the big takeaways? First, AI models are internally juggling multiple possible futures at once. Second, we can actually get a read on their uncertainty by seeing how suggestible they are. And third, and this is the big one, an AI's internal thoughts, its hidden states, hold unique information about what it's going to do next, information that you can't get just by reading the words it has written so far.
And this quote from the paper itself just says it perfectly. The model's own internal activations, they carry information about its future actions that goes beyond the words themselves. It means there's a real internal process going on here, one that we're only just now learning how to listen to. Which leaves us with this final, massive question. We all know these AI models can be confidently wrong, right? But what if we can get better at reading their internal uncertainty? What if we could know when they're truly hesitant versus when they're just blindly committed to a path? Could that be the very first step toward building AI that we can actually understand and maybe, just maybe, finally begin to trust?